Hello, and thank you for joining me here on our YouTube channel, Your Path for Adult Learners, where we offer 24/7 online GED and HISET preparation courses for adults that are seeking to earn their high school credential. You can learn more about our courses at our website at www.yourpathforadultlearners.com. So in today's Focus on the Test mini lesson, I will be reviewing a math problem that will resemble what you'll see on your actual test. So let us get started. So before we begin this lesson, let's look at some rules pertaining to scientific notation. I'll give you a few minutes to review these rules. Please follow me as I discuss them. So when we use scientific notation, it is used to express the values of very large and small numbers. And when we convert these values into scientific notation, we actually rewrite them in the form of a decimal, and then we multiply them by a power of 10. So we're going to move our decimal point to where there is only a single digit in front of it. So let's look at examples 4 and 5. Here we have a very large number, 873 million, is expressed in its scientific notation form as 8.73 times 10 to the 8th power. A positive exponent, such as in this case, the number 8, represents the number of places that the decimal point needs to be shifted to the right. Well, that's if you are converting this scientific notation into its original value. Okay, so if you would actually move this decimal point, which is here, and it's going to be moved to the right 8 places so that it ends here. However, if you were converting this value into its scientific notation form, which is here, you're actually moving the decimal point from here 8 places to here, which is behind the 8, and the decimal point is actually moving 8 spaces forward. So that is one way to remember that if you're moving your decimal point forward, then you're going to give it a positive value. So now let's look at very small numbers, such as in the case of 0.0000023. This value is expressed in its scientific notation form as 2.3 times 10 to the negative 6. A negative exponent, such as in the case of negative 6, represents the number of places that the decimal point needs to be shifted to the left. So if you were converting this scientific notation into its original value, you're actually moving the decimal point here, which will be here, 6 spaces here. And so you're moving it to the left in this case. However, if you were converting this value to a scientific notation form, you're actually moving your decimal point here, and it's moved backwards 6 spaces, and so it will have an exponent which will be negative. So this exponent is negative, and one way you can remember that is to remember that you're moving your decimal point backwards, giving it a negative exponent when you're converting a small value into the scientific notation form. Here's what a test item may look like. 735 million equals, and here we have our 5 options. We have option 1, 735 times 10 to the 9th power, 2, 7.35 times 10 to the negative 8th power, 3, 7.35 times 10 to the negative 9th power, 4, 7.35 times 10 to the 8th power, and 5, 73.5 times 10 to the 8th power. So in order to solve this problem, you are being asked to convert this large value into its decimal form. And in order to do that, we're going to actually move our decimal point, which is here, several spaces forward so that it ends up with one single digit before it. So when we do that, we end up with a decimal value of 7.35. And so now we're going to multiply this value by 10. And in order to determine our exponent, we need to know how many spaces we actually moved our decimal point forward. And when we count, we get 1, 2, 3, 4, 5, 6, 7, 8 spaces. And so we're going to put an 8 here, and it's going to be a positive 8 because we actually moved the decimal point 8 spaces forward. So now when we come over here to our options, we see that option 4 is the correct choice in terms of converting this value into a scientific notation form. So let us look at another test item where you're being asked to convert a smaller value into its scientific notation form. So here you have 0.0000123 equals, and here you have your 5 options. So you have option 1, 123 times 10 to the 5th power, 2, 1.23 times 10 to the 6th power, 3, 1.23 times 10 to the negative 6th power, 4, 1.23 times 10 to the negative 5th power, and 5, 12.3 times 10 to the 5th power. So in order to solve this problem, we need to move this decimal point here until it ends up with one single digit in front of it. So we're going to move it here. So when we convert this value into its decimal form, we get 1.23 with one single digit in front of it, which is 1. We're going to multiply this decimal by 10. And now in order to determine our exponent, we need to determine how many places we actually moved our decimal point backwards, which is 1, 2, 3, 4, 5, 6. So we actually moved our decimal point 6 spaces backwards. So that's going to give us a negative 6. So in order to turn this value into a scientific notation form, we end up with 1.23 times 10 to the negative 6th power. So when we come over here to our options, we see that option 3 is the correct choice in terms of answering this particular problem. So thank you for watching. Remember to like, subscribe, and watch out for more videos to come your way. Remember, you can learn more about our 24/7 online GED and HISET preparation courses by visiting our website at www.yourpathforadultlearners.com.